day 26 in geometry. And today we are going to kind of go all the way to the very beginning of the very first things we learned about in geometry and touch on as many things as we feel we'd like to practice today. So we'll start with our Unit 1 and we'll review the two topics that you will be seeing on the written final. So let me write up here, what is the date? It is Tuesday. Yes, November 18th. Thank you. And pause. So looking at the first thing on our review, it says to construct the angle bisector. So we have not done this in a very long time. So what you will need, if you don't already, you should have a compass. Those are usually at your tables. If there is not one, they're at the front of the room. Feel free to grab one. And when we want to construct an angle bisector, does anybody remember where I need to start with my compass? Say it again? The axis point. The axis point, that's very close to what it's called. Does anyone remember what that point is called? You're correct. That's where we start, right there. It starts with a letter that looks like this shape. Vertex. So we want to start with our point of our compass on the vertex. Put it right on there. And next, does anyone remember what we need to do?
You make like a half circle?
Yeah, we're making like a half circle. That's called our arc. And what we want to do with this is, remember on our angle bisector, we don't want to make that first arc too big or else the other markings are going to be super far away from the angle. So I'm going to close my compass a little bit and make my first arc not gigantic. I'm going to do it like this. And I want to cross over both rays that make up the angle. So start on the vertex, make a small arc. And when we make that first arc, we'll notice that we've created two intersections. What should we do from here?
Mark your intersections.
Yeah, let's mark those intersections. So I'm going to mark that I intersected here and there. And I'll put a point on the vertex where we started. So now I have these two intersections, and what am I going to do with those intersections?
We them as the new starting point.
Yes, these become the new starting points. So our compass, the point of our compass goes on the first intersection. And where am I making the next arc? Should it be inside the angle or outside? Inside, good. So I'm going to tilt this. Whenever you're using this, it can be a little tricky to hold a compass the right way. It helps if you try to put most of your weight on the metal part, so that your pencil can move a little more freely. And I am going to just create an arc going inside the angle. Now, before we make the next arc, it's a really good idea. Take your compass and measure the arc that you just made. Make sure that you didn't accidentally close your compass and make it smaller or open it and make it bigger, because the third arc we make needs to be the same size as that second one. So I've made my second arc. Where does my third arc start?
Starts on the bottom.
On the other intersection. So let's put our compass there. And again, we'll do a third arc inside, and it just has to cross the second one. And now we've created this intersection?
It's very.
Mine too. So I just.
Looks good. It looks good. So now that I have my third intersection, what will I do?
Oh, one.
The line.
Yes, now I have a line that is perfectly centered with the vertex. I'm going to connect the dots. And I have officially created the angle bisector. What's the very last thing I need to do to show that my angle is split perfectly in half? You could measure. If you really want to be certain that you did it right, you could measure these with your, what's it called? Your protractor.
Draw the tick marks.
Tick marks. Technically, for angles, we use something different than tick marks, but that's the right idea.
It's your circles.
Your little parts of circles.
Yeah.
It's arcs again.
Yeah,
We're
arcs.
going to draw the arcs on each angle. So there's an arc here. And if I make that one arc, I need to make the other one arc as well to show that these are the same size. And that's it. Is it all coming back to you?
Slowly.
Slowly but surely.
This came back to me more than that second one.
The second one? So the second one, I bet it'll come back to you once I remind us of that. We have a circle trick for these.
Yes.
Hey, so we got number one done. Do we have any questions about the angle bisector? I feel like it's pretty straightforward. Are we ready to try number two?
Yeah.
I did. You made a heart.
Okay, so there was aren't you just okay, so I know that we did this with the angles, but didn't we do another one of
Yes.
this as well?
We did a perpendicular bisector.
Yes, that's what it was.
Yes.
Okay.
Now, on the final, the reason we're reviewing this one is because this is what you tested
That's the
over.
okay.
Yes. So
Got you.
we could, for fun though, do the perpendicular bisector. I don't know. It won't be on the final. But does anybody want to see that again, or we good?
Again and again.
Again and again. How about we come back to it if there's time?
That's fine.
Okay, so we'll come back if there's time. Let's look at number two now. Now, one very important thing I forgot to mark on number two is this.
Tick marks.
Some little arrow tick marks. What does this mean?
They are parallel.
They're parallel lines. So these lines are never going to touch each other. They're going at the exact same angle. And it says we want to solve for x, and we want to solve for all of the missing angles. So let's see what we can remember about lines and angles. This was a long time ago. Thinking back to when we have, I'm going to do this on a sticky note real quick. When we have parallel lines, so two lines side by side, and then we have a third line that goes through the two lines like this. Just pretend that's straight, and then we need to make it bent. We have a little trick that we can do to help us remember how every angle is related to the other. Remember when we would make the two circles on our angles? And then let's start with the one angle measure that we know, this one. So this would be down here in my bottom circle.
C would be 62.
Ah, yes. See, I already know that it is 62 degrees. How do you know that?
Because of the cross from the 62.
Yes, angles that are right across from each other, or vertical angles,
Are the same.
are the same. They're equal. So right off the bat, let's mark that C is 62 degrees. I know that now. Okay. Is there any other angles that are 62 degrees as well? D, angle D. So remember the other thing is I'm going to color these parts of the circle in as well. If two angles are equal on the lower circle of angles, we can color the same position on the upper circle. Those angles will also be equal. So I know, let me draw my circle here. C is 62. These are in the across positions. D is in the same position, so it must also be 62. What else is 62?
Across from D.
Across
The
from
2x
D,
plus 2.
the 2x plus 2. Okay. So let me move this up.
Does that mean it's equal to 62?
Yes. And we've just written our first equation. I know that this is 62 degrees. 2x plus 2 is 62 degrees. So we have an equation that we can solve. Let's see. So it says solve for x. That was one of the first things we wanted to do. So I'm going to write out 2x plus 2 equals 62. We see where that came from? Okay. So now that I have this equation written, what should I do?
Subtract 2.
Yeah. Let's start solving for x. We'll subtract 2. Two's cancel, then what?
You bring down your x, your 2x
Yeah.
equals.
2x equals 60.
You divide by 2.
Good. Divide by 2. And we get
30.
30.
X
X
equals 30.
equals 30. Perfect. Okay, so we solve for x. We solve for x. We solved for, I know angle C is done. Angle D is done. This 2x plus 2 is done. And this 62 will be started with. How am I going to find the other 4 angles, A, B, E, and F?
Well, if you can just find one of them, you know that the rest of them is going to be the same.
Okay, very good point. If I just find one of those angles, I have all 4 of them. Those are all equal. So how can we find even just one of them?
Use your answer. Do A plus 30 equals 180.
A plus 30 equals 180.
62.
62. Okay, so good catch there. Seth had the idea, what if we do A plus 62 equals 180?
Straight line.
Because it's a straight line. Remember, when 2 angles, or as many angles as you want, when you stack them up and they make a straight line, it's 180 degrees. So I'm going to mark this right here, A and 62, because of that straight line, that makes 180 degrees. So what equation will I write?
A plus 62 equals 180.
Good. A plus 62 equals 180.
You just subtract 62.
Okay. So now we will perfect subtract 62 from both sides.
Your A equals 118.
Okay, and then, yep, 62's canceled, bring down A. And you said 180 minus 62 is
118.
118. Perfect. Perfect. Okay, so we solved for angle A. That's 118.
No.
So do I need to do that? Do I
No,
need to
because
do
it's all 180. No, because if A equals 118 and B equals 118, E equals 118, so does that.
Yes. Jessica, can you explain why all 4 of these are equal?
Because they're across from each other. And
Yes.
if you find the first angle, which we just did, then you know B is gonna be the same, and so is E and F.
Yes, yes, yes. So if I know that A is 118 degrees, B is right across from it. Angles that are across from each other are equal, so that's 118. E and F are across from each other, and they're in the same position as A and B. So 118, 118. Done. That one looked scary, but I feel like once we got going, we remembered a few things.
So it's just A,
Yes, so here let me write that out in meter so that we can see everything in a line. I'm going to start by saying x equals, since that's the first thing I asked for. So x equals, we found out that was 30. And then A
equals 118.
A is 118 degrees. B was also
118.
C was
62.
good, 62 degrees. The D
Is 62 degrees.
good. D was 62.
E is 118.
E is 118.
F is 118.
F is 118.
And then the other two that don't have letters is also 62.
Perfect. The other two without letters, or this one here, these
Yeah.
were both 62. Perfect. Okay. So on the final, if you decide to take the written final, you'll have a question very, very similar to this. And I will give you blank spots to write down your answers. So that way you don't have to rewrite everything and try to organize it. I'll have spots for you to write. Okay. So if you're wanting to take a note and you're worried you may forget some of this, again, this is a great thing to draw your two circles. And just remember, if they're the same color, they're equal. If they are different colors, they add up to 180 degrees. So, same color, equal. Different color, add to equal 180. Okay. So, good little review there. Do we have any questions at all about anything we just did? Anything? We feel okay about that? Okay, so let me pause this for a minute and let everybody catch up writing. See if you people still writing stuff. So I will give you just a minute here. I'll look around to make sure y'all are ready before we move on to the next thing. Anybody still writing? Anybody need more time? You still finishing up trying to clean?
I'm done.
Oh, you're done. Okay, perfect. All right. We unpause.
Let me
and-
see the
Oh,
first one.
I was still recording. Whoopsie. The first one, this one here.
Oh, okay. I see.
Yes.
Mhm.
And that's all.
Yeah, I got it.
Okay, so I am going to move on, tear this out, and we're just going to continue with a review of absolutely everything today, making sure that we all got it. So going on to, there were, I believe, 2 more things we learned about in Unit 1. And those 2 things were the midpoint and distance formulas. Midpoint distance formula review. Okay. And these are types of problems where we're working with coordinates. We have x value, y value. And I may give you 2 coordinates, 2 points. And I say, what is the midpoint of these 2 points? Or what is the distance between these 2 points? So we need to know the formulas for both of these. And I'm going to give you them. So first, let's write the midpoint formula. And I like to do my formulas on sticky notes. So, midpoint. Midpoint. All right. M equals. This is the one where we have parentheses, big parentheses, and a comma. And then I'm going to split both of these in 2. And the first slot on top of our divided by 2 will be x1 plus x2. x1 plus x2. What do we think goes in the next spot?
Y1, Y2.
Yes, y1 plus y2. Perfect. Perfect. Okay. So there is our midpoint formula. And let's work with just that first. So if I were to give you 2 coordinates, this will just be a guide to how to label your coordinates. Remember that this would be x1, y1. Those go in the same coordinate. Then you have your x2, y2. Just as a reminder how we label these. So I will zoom out of here. Let's do an example. I'm going to scoop this up just a little bit. So first, I will ask you to find the midpoint of the line segment that has these endpoints. We'll go with 0, 4, and -3, 5. We're going to find the midpoint. So whenever I'm working with coordinates and I want to find the midpoint, what should we always do before we start plugging things in? Label. Label your coordinates. It feels like a silly step, but I promise you it is so worth it to take the extra second it takes so that you don't mix yourself up. So I'm going to start with x1, y1, x2, y2. And once I've labeled everything, where do we go from here? Plug it all in. So I like to draw out my big parentheses and leave them kind of empty. So Here's that. I'm gonna be adding two numbers, dividing by 2, comma, and if it helps, I need to put parentheses. And then I know I'm gonna be adding two numbers over here for my y's, divide by 2. So we're only plugging in 4 values. We only have 4 values. What goes in the first 2?
0.
0
And -3.
and -3. Good.
And the second one is 4 and 5.
Good. The second one will be 4 and 5. Okay. Once I'm plugged in, now what? Solve. How? What should I be doing first?
You can do both of your x's first,
Mhm.
or your y's. It doesn't matter.
Yeah, it doesn't necessarily matter which one we do first, but basically, the best first step is to simplify what's on top of both of your fractions. So first, I like to go left to right. Let's do 0 plus -3. What does that give me?
-3.
It's just -3. Good. So -3, I'm going to cross that out, bring it down. And what else comes down from the x value side over here?
2.
The 2 over
divided
2.
by 2.
Good. I'm going to go ahead and also bring down parentheses. Bring down that comma. And now let's look at y's. I have 4 plus 5. 9. Good. So cross it out, bring down my 9. What else comes down?
Your 2.
My 2. Good. Divided by 2. My big parenthesis here. And we're almost done.
You take the -3 divided by 2.
Yep.
It's a -1.5.
Yes. -3 divided by 2 is -1.5. Comma.
And your 9 divided by 2 is 4.5.
Yes. Now 9 divided by 2 is 4.5. Perfect. And that is our midpoint. That's our answer. Perfect. Good, good, good. So I'm going to write over here, this was our midpoint. Good, good, good. So now that we have our midpoint, do one of those problems. Let's also do the distance between those 2 points. And in order to do that, we need our distance formula. So I'll write a separate sticky note that says distance. And our distance formula goes like this. This is the one where we have a great big square root. And inside the square root, instead of 2 addition problems, we have 2 subtraction problems. So this is x1 minus x2. All of that in parentheses. And whatever that number is, it gets squared. Plus, we're going to have y1 minus y2 squared. So I'm gonna bring down those coordinates just so that I have them in front of me again. It's the same, we'll do 0, 4, -3, 5. It's the same points we've already used. And I'm just gonna bring down the labels that we gave them as well. Our x1, x2, and all of that. Got this all set up. Let's practice using the distance formula because it works a little bit differently. We're at the step now where we have our coordinates labeled and we know our x1, x2, y1, y2. What should I do at the next step here?
Plug it in.
Plug it in. Good. So I'm just going to rewrite all of the parts of my formula that I don't have to plug things in. So b equals, and then I'll draw a big square root. And then I know I'm going to have something minus something else squared plus over here another something minus something squared. Giving myself some length. So, looking at our formula here, what goes in my first two blanks?
0, -3.
Yep, 0 is x1 minus, keep your minus, -3. So it's minus -3. Okay, and now I want to plug my y's in. So what's next?
4 and 5.
Yes, 4 and 5. So I have 0 minus -3, and I have 4 minus 5 in my parentheses. So everything has been plugged in at this point, and now we need to simplify. So we really got to be careful and think about the order of operations.
Do parentheses first.
Yes, parentheses first. So what I'm going to do is at each step, I'm going to kind of just highlight what we're doing just to help us see what's happening first. So first, let's do what's inside the parentheses. So what is 0 minus -3?
+3.
Good. +3. So remember that minus negative cancels, turns into a plus. 0 plus 3 is +3. Okay. What comes down with that 3?
The square.
Squared. So then I'll bring down my plus. And 4 minus 5.
-1.
-1. What else comes down?
Square.
Squared. Good. And last but not least, something else gotta come down.
The d equals the square root sign.
Yes. My d equals big square root. D equals big old square root. Okay. So what are we doing now?
You're gonna take 3 times 3.
Yeah, 3 squared means 3 times 3, which is
9.
9. Good. I'll bring down plus.
-1 times the south is +1.
Good. Remember, anytime we have a negative number being squared, the answer is always positive. Because I'm taking -1 times -1, which is +1. Okay, what else comes down?
The d equals square root sign.
Yep, d equals square root.
You saw that 9 + 1 is
Yeah.
10.
Good. 9 plus 1 is 10. Square root of 10
is 3.16.
So I'm going to take my calculator in case it has been a while since you've used the square root function. I'll remind you all the way that we do that is you just push the second button, the blue button, and we're going to go all the way down to x squared. You see your square root, click on that. There's my square root. Type in 10, enter. 3.16. 3.16. And that is our answer. That is our answer. Too bad, you guys. That was pretty good. That was pretty good. That is everything from Unit 1. Absolutely everything from Unit 1. That where we can still see kind of all of it. And I will give you guys a minute to finish copying that down. Okay, so that's Unit 1. We reviewed it. I'm gonna flip this. Before I do, I'm gonna call this page. I'm gonna call that page 2. I'm gonna say our do now was kind of page 1 because it's a continuation. So we finished our Unit 1 review, and now we're gonna go to Unit 2. So, carrying that out and Unit 2 review. Triangles. Let's talk about all the things that we know about triangles. Because triangles have some pretty special things that are always true about every single triangle, no matter what. What do we know about the angles in a triangle? Give me one thing you might know about a triangle's angles. Just one.
They're all the same.
They're all the same. In every triangle, all three are the same.
Not the same. Not all right.
They all have different sides, like each side.
Okay, they got like different like measurements.
Yeah.
Yes. Is there a specific number that we can say the angles always add up to?
3.
There's always 3 angles. What about the degrees? Say it again. 180. Triangles have 3 angles that always add up to 180 degrees. Good. So I'm going to draw a triangle. We're going to write 3 sides, 3 angles. And then beside the 3 angles, I will say add up to equal 180 degrees. Always, always, always. So that's a good thing to know. Now, we do want to talk about sides as well. There was a special thing we learned about called the triangle inequality theorem. And that was where we talked about, like, I would give you 3 side lengths and I would ask, could these be a triangle, yes or no? I want to write that out real quick. We would have A plus B must be greater than C. Side length. If I'm naming a triangle with the sides A, B, and C, which side is always C? The longest side.
Hypotenuse.
Good. Or the hypotenuse if it's a right triangle. So C is always the longest side. A and B can be either of the other two sides. That one doesn't matter. As long as you're picking the two short sides. The longest one is always C. So let me give you an example of where we would be using this A plus B is greater than C. So I'm going to write down here. Example. It might say something like this. Could the three sides be a triangle? And then here would be the three sides. Let's go with 58 inches, 32 inches, and let's go with 41 inches. Yes. So right away, 58 is my C. 58 is my longest side. So what should I do with the remaining sides? Add them together. So I'm going to add 32 plus 41.
73.
73. Yes, ma'am. So I'm going to write down here 73 because that's my A plus B. So I add those. I get 73. And let's write the rest. We have greater than C, which we said is 58. Is this true? 73 is bigger than 58?
Yes.
Yes, it's true. 73 is bigger than 58. So this would be one where you circle yes or no. So if we were going to say yes or no, could this be a triangle? Yes or no?
Yes.
Yes, because it's true. So I'm going to write true, and then you would say yes. This could be a triangle. Do one more similar to that, just to make sure we got it. What if I gave you 6 inches, 39 inches, and 15 inches?
39 is the biggest.
39 is my biggest, so I'm going to circle that. What should I do with the other two?
Add them together.
Add them together.
It'd be 21.
Good. So 15 plus 6, you're correct. That is 21 inches. And we'll copy down the rest. Greater than C is 39. And is this true? 21 is bigger than 39. No, that is false. Not true. So I'm going to write not true. This one, your answer would be no. No, that is not true. Okay. Awesome. Good. So you may see a question similar to that if you're taking the written final.
So much.
Explain. Okay. So there's a quick review of our side lengths with the triangle inequality theorem. Now I want to talk about specifically right triangles. So I'm gonna give this another kind of blue title. And with right triangles, we're not gonna talk about special right triangles just yet. First, we're gonna start with just a regular right triangle. And this is where we use Pythagorean theorem. So Pythagorean. Big words in this class.
You're not, that's not how it goes.
No, I will never. I'm not going to give you a spelling test. Promise. Promise. Does anybody remember the Pythagorean theorem? I bet somebody does.
A squared.
Yep.
B squared equals C squared.
Perfect. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Okay. And let's look at an example. Say I have a triangle and it is a right triangle. So it has a 90-degree angle. And I don't know this length, but I do know that the hypotenuse is, let's say it is 31. We'll go with feet. And then my other side length here is going to be 10 feet. So 10 feet, 31 feet, and I'm missing one of my sides. Once you have that copied down, I want you to start thinking about which sides could I use for A and B, and which side has to be C.
Is 631?
Yes, C is 31. C is always the longest side, and it's always across from 90. So here's 90 degrees. That is my hypotenuse. That's always C. Very good. Now my other two sides, 10 and X. Does it matter which one I use for A and B? No, it doesn't. You can do either one. If it were me deciding what to do, I like my X or my variable to come at the beginning. So I'll probably, yeah, I like that. I'll probably use this for my A, and I'll make B my 10. So now I've decided A is my X, B is 10, C is 31. What should we do?
Plug it in.
Plug it in. Plug it in. So instead of A squared,
It'll be X squared.
good, X squared. Bless you. X squared
10 squared
plus good. B squared, so 10 squared
equals 31 squared.
equals C squared, 31 squared. Okay, and I'm going to draw a line down the middle. My equal sign just to keep me organized. It's easy to make a wrong step with a problem like this. And before I start trying to solve for X and moving things around too much, what is one of the first things I need to do here? It's a good first step.
Oh, we want to square them all.
Yeah, let's square them. I've got 10 squared and 31 squared.
That's where something
Good. 10 squared is 100. Ooh, big number. 31 squared is 961. Okay.
X squared is 2x.
2x? So this would be x times 2 if we got 2x. We actually, since we don't know what x is, we're just going to keep it the same for now. We're going to keep the x squared. So bring that down. We don't know what x is yet. So I want to get x by itself. What's a good next step to take? Yes, subtract 100.
Would be 861.
Good. So that'll leave you with 861 over here. And what comes down?
X squared.
X squared again. Good. So now I have x squared equals 861. Am I done?
No.
No. How do I get just x? I don't want x squared. Square root. So remember, the opposite of a square is a square root. So that is the same thing we used for the distance formula. We need to square root both sides. And let's see. Second square root button again, that's right here, x squared. And now I'm going to type 861.
Would be 29.34.
Good. We will get a funky looking decimal. Bring down x equals 29.34. What are my units?
Square. Feet. Or feet.
Feet. Good. Just a length. We're not doing area, so it will just be feet. Good, good, good. We did it. There it is. Just a minute. Everybody get that written. And we're going to start looking at special right triangles. These are one of the trickier things we've done all term. So if you're already done with this, not a bad idea. Maybe try to go back and pull out your special right triangle notes. That's what we're going to do next. Okay.
Unit 2? Read
Yes, Unit 2. We're reviewing Unit 2 right now. So now what I'm going to do, and if you guys did your notebook similar to the way I did, I've made these tabs. Oh, that's out of 2. So I'm going to go to my tab that says Special Right Triangles. And look at this. Now I don't have to write it out again because it's right here. I love that. So we have 2 different types of special right triangles. We have a 30, 60, 90 and a 45, 45, 90. And if you remember back to the day that we wrote these notes, it was all the way on day 11 of October. On the next page of this note, we wrote out some steps. How helpful is that? Oh. So we're going to use these steps and just make sure we remember how to do it. Make sure we remember. Let's see. So I am going to give you, we're going to use the same point where A is at the bottom on the 90. And then, or hang on, no, we're not going to use the same point because it's different on the practice final. I'm looking at that now. I am going to move that to the side for a moment. Write page 4 and title Special Right Triangles. That's what we're doing now. Page 4. This is still Unit 2. Unit 2 review. And it's special right triangle. I will be giving you guys a break here in just a second. So let's look at a 30, 60, 90 triangle first. And we will give an example point here. It will look like this. So we are still going to draw a picture. Sorry. So here's our 90-degree angle. I'm gonna write 30 up at the top, 60 at the bottom. And we're gonna label the top with D, bottom E, and then F. And I am going to give you a few values and then we'll find a few values. So, given, and this is exactly how it will look on the final. Given, find. So, I'm going to give you that DE is 40 inches. And we need to find the F and EF. Yes.
I think we write the line and then finish.
Why did we write the line over the letters?
I'm just
Excellent
curious.
question. No, that's a good question. Does anybody know the answer? Why did I put a line over the two letters?
Doesn't that just indicate a line segment?
Yes, it just indicates that we're talking specifically about the length of that line segment. So, good question. Good question. Right. It never hurts to make sure. So, I know DE is 40 inches. I'm going to pull out my note for special right triangles. And I'm going to look at the way I have a 30, 60, 90 label. So I see this here. I see that there's some X values. What should I do to start? What's the first thing you should always do? Label, 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 label. I'm going to label my triangle picture. We could also label our values. I'm going to do my picture first. So what should I label EF on the bottom?
X.
X. Okay. What about DE?
X. Or X radical 3.
Yes, X radical 3. And my hypotenuse is 2F. Okay, so I have everything labeled. And then I'm going to flip to the next page of my notebook and look for my steps. And it says step 1, label your side lengths with your X values, which we've done. I'm going to also label down here. From D to E, I know it's 40 inches. I'm going to find D, E. What's it also labeled as? X radical 3. So both of these are equal. I'm going to write X radical 3. What is DF? Yes, my 2X and EF. That's X. Yes, yes, yes. So I've labeled everything. Everything is labeled. What do we need to do now? Solve for yes, let's find what X is. So we are wanting to make a note on here. I'm just going to say 1, label. 2, solve for X. So the reason I wanted you to label your picture and your given values, your find values, is because it's going to make solving for X a little bit easier. Because now I don't have to think so hard about what equation am I going to write? What equation will I use? I've already written it. What is that equation? 40 equals X radical 3. So, good. We're going to use 40 equals X radical 3. I'm going to pull this out to the side. For step 2, solve for x. 40 equals x times radical 3. How do I solve that equation?
Figure out what.
You could figure out what radical 3 is. I'm going to tell you it will give you a super long decimal that will never be super accurate. You could do that. But you would still have to do the next step. Does anybody know what that next step would be? How am I going to get rid of this?
Is it you dividing?
Yes, you divide it. We need to, this is just x times, radical 3 is a number. It's just a number. So we still type it in with the square root symbol and then 3. But we can divide by that square root of 3, that radical 3. So I need another color to show that's my equation. Here's my next step. Divide by radical 3 on both sides. And when I divide by radical 3, what happens over here with my x? Yeah, those radical 3's will cancel out. And I can bring x down all by itself. Bring down my equal sign. And then we'll solve the rest. So I'm going to type 40 divided by second square root of 3. Enter.
It's 33.09.
Perfect. 23.09. That is my x value. That wasn't so bad, was it?
Or you could do 23.
You could. I'm going to put 09 since we would round down. The next decimal is 4 after 9. So x is 23.09. We've solved for x. How do I use my x value once I've found it?
You plug it into your 2x.
Now we plug it in to solve for the other side. So that would be step 3. Plug x in to solve other sides. So I know that df is 2 times x. So what will I do to find df?
Forms.
Yeah, go ahead. You're right.
The answer is 46.18, but it's 23.09 times 2.
Good. You're just going to take that 23.09 times 2, and if you are correct, you will get 46.18.
This is just 23.09.
Yeah. We already found x, and EF is x. So, it's 23.09. Excellent. Inches. Very good. Good. The only way that a problem like this could be different is if you were already given your x value, then all you have to do is plug in. You don't have to solve first. Or if you were given from D to F, you would still solve for x, but you wouldn't divide by radical 3. You would divide by 2. Okay. And we are at perfect time here. It is 2:04. I think this is a good time for a break. We have worked very hard today. I am going to pause this lesson recording here and give you guys a break. So let's do a 15-minute break. Just be back in here at 2:20. We are back from our break, and we just finished reviewing our 30, 60, 90 special right triangle. So now let's also, bless you, look at 45, 45, 90. So I am going to draw another picture here. And we are going to label, wow, okay. We're going to label these 45, 45, and I'll put a little square box for my 90. And we will label on top A, our 90 is B, and the other 45 will be C. This time I will give you, given is that BC equals 28 inches. And we will need to find AB and AC. Okay. So we've got our problem set up. Now we're going to revisit our steps. I'm going to go back to my special right triangles page in my notes. And let's look at how we label a 45, 45, 90. These are nice because two of our side legs are the same. We have X and X for the legs. Our hypotenuse is X radical 2. So I'm going to start by labeling my picture. What would I label from A to B? A, B. What is this going to be?
X.
X. Good. How about B to C?
X.
Also X. And AC, the only one left. X.
Two.
Perfect. Radical 2. I'm also going to label my given value and the values I want to find. So from my given BC, I know it's 28 inches. What else is BC now labeled as?
28X.
Not 28x. So what I'm saying is I know that BC is 28. BC is also x, right? So instead of 28x, this is where I would say BC equals 28. I can also say BC equals what? X. Yes. And usually our first step is to solve for x. We already have x here. So if I already have 28 equals x, I'm going to pull this out and say x is 28. I already know my x.
That also make AB the same.
Yes, AB is also x, and I know x is 28, so let's go ahead and say 28 CSF inches. Good. Okay. Now, AC, what did we label that as?
X radical 2.
X radical 2. I know what x is. I know AC is x radical 2. How can I use my x value to find the number for AC?
Plug it in.
Just plug it in. So I'm going to bring this over here. Instead of x radical 2, 28 radical 2. And we are going to type that in our calculator exactly how we wrote it. I don't need to divide or anything like that. We can just type 28 second square root to get my radical 2. Enter. And that's it. That's your answer. 39.597979, and then it keeps going. We could keep that as 59 if we don't round. I am going to round that to 39.60. So 39.60 inches. There we go. Any questions about either of those? Okay, I'll pause this and allow you guys time to finish writing that if you are still writing. We're gonna move on after this. Let's see. We're moving on to Unit 3 next. That's it for 2. So, starting a new page now, I am going to have us move on to Unit 3. It'll be page 5 of our review today. And I'm going to title this Unit 3 Review. For this review, we are looking at quadrilaterals, polygons, okay. And one thing we want to remember is that on our final, if you're taking the written one, there will be a part where you need to be able to name what type of quadrilateral a shape is. So I'm going to give us a little guide as a reminder of the 4 different options we will have. First, we will have, I'll draw 2 tilted lines that are parallel, 2 other lines that are parallel. And then I'm going to label some things. First of all, I'm going to label 2 tick marks on top, 2 tick marks on bottom. What does that mean whenever 2 sides have the same number of tick marks? They're equal. 1 tick mark on the other side, so those are equal too. So yes, these are equal. And then what did you say?
Equal.
Yes, all equal. Good. And now we might label the angles. I'll put 2 arcs there. And
On the bottom.
yes, 2 arcs here. They are diagonal from each other.
This one.
1 here, 1 there, diagonal. What is the most specific name we could give this quadrilateral?
Parallelogram.
Yes!
It's opposite. Yeah.
This is a parallelogram. That's all right. Parallelogram. Parallelogram. Okay. Next, we're going to take a parallelogram and we're going to basically take the points and shift them, make all the angles equal. And that will look like this. So we still have opposite sides equal. But now, instead of just opposite angles are equal, all 4 angles are equal. And they are all 4 90 degrees. What shape would this be?
Triangle.
Not a triangle, that's 3 sides, remember? 3 This one starts with the letter R. Not rhombus. Rectangle.
Yeah,
Rectangle.
yeah, rectangle.
Yes.
Sorry.
That's okay. This is why we review.
Yeah.
Rectangle. Good. Rectangle.
For sure.
Okay, so we have a parallelogram, a rectangle. Now, we're going to draw what is very similar to a parallelogram, except now,
Numbers.
you predicted it perfectly. Now all four sides will be equal. You are correct. That will be a rhombus. And a rhombus, you'll know it's a rhombus because every side is the same. All four sides have one tick mark. And that we write RHOMBUS, rhombus. Opposite angles are still equal, but they're not 90 degrees this time. 2 arcs here, 1 arc here. And the last one we'll put on here, just like from parallelogram to rectangle, we kept the sides the same, but then we shifted to make the angles equal. We'll take the rhombus and shift it to make all four angles equal. Keep all four sides equal. And then one tick mark on every side. All four angles, 90 degrees. What is this shape?
Where?
A square. Good. F-U-U-A-R-E. Square. Good, good, good. Now, for all four of these, we can use the same formulas for finding perimeter and area. So, here's what we'll do. All right, P-E-R-I-M-C-E, perimeter. Let's give a formula. I'm gonna write that in a different color, actually. E equals. We find the perimeter of a quadrilateral. There's a formula we could use, or we can think of it kind of with words. Because one thing we know about perimeter is that perimeter is the length around the shape, on the outside of the shape, all the sides.
Equals.
Equals N times S.
That would be for a regular polygon. If all the sides are the same, I can do that.
How do you say it somewhere? Is it base times height?
Base times height is area.
Okay.
That's right. Base and height is
We're on
area.
track.
So here, let me write that below here.
Base
Area.
on the side.
Say that again.
Base inside.
Base and side is going to give us perimeter.
Okay.
Good. So perimeter, let's start with that. Remember, there's a base, there's a side, and that's half of it. There's two of those because here's my base. I'm gonna write B here, and there's a side here. Base has two tick marks. There's another base here. And there's another side here. So I need to take those times 2. 2 times base plus side. Yeah. Now area is the one where we use A equals base times height. Now I'm going to get height a different color. And we're going to label height on these shapes as well. So on my parallelogram, my height is not labeled yet. The height is going to be up and down from the bottom to the top. And it will usually be a dotted line with a 90-degree angle. This is our height. Where would the height be on a rectangle?
The middle.
In the middle. On the side, yeah. The side, because it's already got that 90-degree angle, is the same as the height. The side and the height are the same on a rectangle. And then the bottom and top will still be the base. Now on a rhombus, all 4 sides are the same. So technically with a rhombus and a square, because the sides are the same, we could do the number of sides, which is 4 times one of the side lengths. So these we could do S times 4 if we want. If you're wanting to just keep it the same and not overcomplicate it, we'll still label our base on the bottom and top, our sides on the outsides here. So side, side, base, base. Now our rhombus height is like our parallelogram, where we go down with a dotted line. So I'll do that again, down, dotted line. Here. Height is the pink dotted line. Base is here. Now a square is like a rectangle with the height. Where is the height on a square?
Sides too.
Yeah, it's the same as the sides. Both of the sides could be used for height because they're all the same. Good. So let's give you guys a second to label all of your stuff, and then we'll do an example of one of these. Let's see. So let's say I have example. Draw this shape. Want to look at the markings. Don't look at what it looks like. Look at the markings on the sides. What type of quadrilateral is this?
Rhombus.
Look at the markings.
Oh, sorry. My vision's not that good.
You're okay here. Now tell me.
Ah, okay. That's a parallel.
Yes, parallelogram. It looked like a rhombus at first. But now we can see there's actually 2 tick marks here, which means my 4 sides are not the same. So, because of that, this is a parallelogram. So, parallelogram. Okay, now let's say I give you these measurements. I'm going to zoom in on this again. It's a little bit small. Right here, let's say this is labeled 22 inches. And then on the bottom, I will label 40 inches. And on the side, I will label 38 inches. They're very close. So this is where we would want to know the perimeter and the area. So I've got my parallelogram labeled. And a good step for these problems is honestly the best first step for any problem you'll ever do. Label everything. Label everything. So once this is drawn, we'll want to look at each of these numbers and decide what is my base, what is my side, what is my height. So, what is my base, side, and height?
40, 38.
Yes, yes. Perfect. 40 is my base. My side is 38. My height is inside here. Good, 22. Now that I have these numbers, we can use them. Let's find our perimeter. Somebody tell me what to do.
Area, just do 40 times 22.
Base times height. Yes, yes. Area is base times height. Base is 40. Height is 22. Okay, so we'll type that in. 40 times 22. What do we get?
180.
Perfect. 880. So whenever I write that in my area spot, 880, what are my units for area? Inches square. Good. Area is the only one that has square. So now I've got area. How do I find perimeter?
E equals 2 times 40 plus 38.
Good. P equals 2 times base, 40, plus side, 38. And we've got 2 options for solving this. You could distribute the 2, or you could add first and then times 2. So, which one are y'all doing?
I went ahead and I added the parentheses together.
Let's add, what does that give us?
78
78
times 2.
times 2.
I got 156.
Perfect. 156. And you are correct, it will be inches. Good. Good, good. Okay, so on your final, and you'll see this on the practice final tomorrow, you will have 2 questions like this. Just 2. I think the trickiest part is remembering to look at your tick marks to help you decide, and also remembering which one is your base, which one's your height, which one's your side. It's always good to label things first. Okay. Any questions about these types of problems here? Okay. Are we ready for the next part of Unit 3?
The top.
Okay, I'll wait for you. I'll wait for you. Okay, so moving on to page 6, more Unit 3 review. And now we're gonna have some regular polygons. And regular polygons, remember, are the ones where all sides are the same, all angles are the same. So all sides, all sides are equal. All angles are equal. And we name regular polygons by the number of sides they have. So I'm going to write here number of sides. And here I'm going to write name. So the smallest number of sides we can have is 3. What kind of polygon has 3 sides? It's like this. 1, 2, 3. What is that? What is that? That's a type of one. You said acute?
Yeah.
That's type of it. It's what we talked about in Unit 2. Starts with a T. Yeah. What is it? T. Tell you. It is a try what? Triangle. It's a triangle. Good. Good. So a regular polygon with 3 sides is a triangle. What about 4 sides?
Clear.
Square. Good. Okay, now I'm going to stop drawing pictures for the rest. I'm just going to write the number. Anybody remember what a polygon with 5 sides is called? You'll have all of these on, there's a handout. Let me pull that out real quick. You pull that out. It was the black and white handout. that had all the shapes on it. Here is it. Here it is. And if anybody needs an extra one of these, I have extras. This one. I guess they said quadrilateral, but if it's regular, it's a square. Oh.
Yeah, the one with the cube.
Yeah, so you're right, square. So I'm gonna write square or quadrilateral.
Wow.
Yeah, no.
Okay. So, what's 5 sides? Pentagon. Yeah, right here. Does anybody need an extra one of these? By chance?
I might.
You might? Okay, I have tons of extras.
Okay.
Right up here. Here. So 5 sides is pentagon. What about 6?
Hexagon.
Hexagon. Good.
You want that? Sorry.
What about 7?
Hexagon.
Heptagon. Good.
See ya.
See ya. 8. Octagon. Good. 9. Good. Nonagon. 10.
Hexagon.
Decagon. 11. Is it hendecagon?
Yes.
Yes. Hen. Decagon. 12.
Bacon.
Dodecagon. Good. Dodecagon. And
I have a copy of this.
you want a copy of this?
Yeah.
I can make a copy. Absolutely. So these are the different names for shapes with different sides and the number of their sides, regular polygons. So remember, whenever we know the number of sides after you've counted them, that might be part of a question. So, like, for example, let's say I'm going to draw a shape here. 1, 2, 3. Okay. I'm going to put some tick marks on it.
It's gonna be the side.
Yep, that will be the side length, all the things I put tick marks on. And I will tell you that the side is 30 inches. And we'll say that this thing here is 41 inches. First, what type polygon is this? Count the sides. 5 sides. So 1, 2, 3, 4, 5. So if it has 5 sides, what type is that? Good. Good. Pentagon. Good. Then we will find our perimeter and our area. We'll write our formulas down for this too. So, perimeter. Y'all told me just a minute ago, what's my perimeter formula for a regular polygon?
P equals N times S.
Yeah, P equals N times S. And what does N mean?
Number of sides.
Number of sides. And S is our side length. So, how will I find my perimeter here?
Side 30.
Yes, my side is 30. Here, I'll label things. S is 30. And we just,
Base is 4.
so let's see. For these, we need a side we need a number of sides, and we need,
The number is 5.
the number is 5, good. And we don't need this little a yet, so we'll save that for later. So how can I use my 30 and my 5 to find perimeter?
So,
Times, multiply them. Perimeter is n times s. N is 5, s is 30. So P equals 5 times 30. And what do we get? Good. 150. And what would our units be?
inches.
Inches. Perfect. Okay. Now going back, I'm gonna write our area formula as well. Anybody remember the area formula?
So, perimeter times bottom over 2.
Good. Perimeter times a apothem divided by 2. So, before we use the formula, what is our apothem? 41. Perfect. So, let's find our area now. Area equals. You know what I need to write, tell me.
Fifty. 150 times 41.
Good. 150 times 41, that's perimeter times apothem. All of it divided by 2. And let's see what we get. I got 150 times 41 gave me 6,150.
Same.
Good. And I'll divide by 2. And I get 3,075. You guys get the same?
Yep.
Perfect. So my area is 3075
Inches squared.
Yes, inches squared. Area is squared. 3075 inches squared. Perfect. Perfect. Okay. That is everything from Unit 3 that will be on this quiz. Or final. That quiz. So I'll give you guys a minute if you are still writing any of this. And we're going to move to the last unit, Unit 4, our circles next. So I'll pause this and let me know when you're ready. Moving on, Unit 4. This might be the most we've ever written in a day. Last but not least, circles, which should be fresh in our minds. We've been learning about it. Unit 4. Circles. And on the written final, I am only asking you to be able to do area and circumference, radius and diameter. I'm not even doing the segments or anything. I just wanted to teach that to you. I won't test you on it. Page 7. I know. I mean,
I think everyone in this class is wrong.
if they've been here, they're doing good. If not, Yes. Okay, so I have a circle. In my circle, I'm going to put a center point. And from my center point, I'm going to draw a line. What is this line called?
Radius.
A radius. R. So that is my radius. Now, if I were to extend that radius and draw a line all the way across, let me get another color here. Not blue. Radius is just the red. This blue line that I've drawn now that goes all the way through the center from one edge to the other, what would this be called? Diameter. Good. D for diameter. We are going to write our formulas here. If I want to find area, formula would be A equals, that's my area formula here.
5 times radius squared.
Good. I times radius squared. Squared. Circumference, C-I-R-C. F. Circumference C equals. I have two different ways I could find circumference.
5 times D,
Good. Pi times D or
2 pi times radius.
good. Pi times diameter or 2 times pi times radius. So there's our formulas. Now, we can check this. So, let's say I have, for example, circle right in the middle. And the question that you'll be asked on the final is to find the area, the circumference, and to fill in all the values for radius and diameter. So it will look like this. Radius, diameter, area, circumference. Let's get you this. Say, get rid of these 6 inches here. Here's our first example. Copy it down so you can focus on answering before you're trying to draw it. Or focus on drawing it before you try to answer it. So, right off the bat, we want to decide what measurement have you been given for this circle? What is 46 inches? Diameter, good. So I know my diameter is 46 inches. I'll fill that in. before I try to find area and circumference, how can I find my radius?
Divide 46 into 2.
Divide it by 2. Good. Radius is half the diameter. So I can do radius equals 46 divided by 2. And what will that give me?
23.
23. Good. And radius, our units are going to be the inches. Perfect. So now I have a radius, I have a diameter. How do we find the area?
A equals I times radius squared.
Good. A equals pi times radius squared. And which number, 23 or 46, we plug in here? 23. 23. Okay, so we will just type that in. And in case we forgot, on our calculators, the way to get pi is the second blue button and then that up arrow right above your division symbol. There's pi. So I have pi 23, the x squared button, enter. And that's the number I got.
That's what I got as well.
Perfect. 1661.90. So my area 1661.90. What are my units?
Square.
Inches squared. Area is squared. Inches squared. Good. Okay, so I've got my radius, my diameter, I've got my area. Let's find our circumference. How do we do that?
Use the second circumference formula.
Okay,
I used C equals pi times diameter.
perfect. Pi times diameter. So pi times 46. Really good. Good, good, good. Okay, so type that in. Pi 46. Enter. And I got 144.51 inches. Good. That's it. That's everything we've learned in 8 weeks.
Okay.
And it's 3:21. We did it all in our class time. That's good.
So smart, guys.
We're so smart. Okay, so if you decide to do the written final, this hopefully has been helpful for you. If you are not doing the written final, you're doing one of the other options. I'd still love to see you come in tomorrow so that you have time to work on whatever option you're doing. Maybe talk to me about what will work, what won't. I can get you any extra copies of things you need.
Let's do that.
Perfect. Thank you. Thank you.
Thanks.
No problem. Okay, so that's it, y'all. You guys are free to go. We do have 8 minutes left, so you're all free to stay if you have questions for me or if you want me to make copies of things for you. Today's a good day to do that. So that is it.